Let's be honest, we're all living on video calls these days, right? Job interviews, big business deals, just catching up with family. It all happens right through our webcams. But as this has become our new normal, something pretty sneaky is hiding in plain sight. So I have to ask you, is the person you're talking to on screen actually real? It sounds like a crazy question, but it's one we seriously need to start asking. Because right now, AI can swap out a person's face with someone else's, live, in real time, and it's getting terrifyingly good. They're called real-time deepfakes, or RTDFs, and they're already doing some major damage. Just take a look at this number. $620,000. That's exactly how much money a man in China lost. A scammer got him on a video call, pretending to be his friend using a deepfake, and convinced him to transfer all that cash. And you see, this works because it's not just a cool tech trick, it's a psychological weapon. It literally hijacks the trust you have in a face you know and turns it against you. So how in the world does this technology even work? Well, if we want to beat these fakes, we've got to understand how they're built first. So let's crack the code. The best way to think about it is like a super fast digital assembly line. First up, you have the face detector, which finds the scammer's face in the video stream. Next, landmark detection jumps in and maps out all the key features, the eyes, nose, mouth. Then comes the face swapper, which is really the engine of the whole operation. It takes that map and generates the target's face to match the expression. And finally, the blending operator digitally pastes that new face onto the scammer's head and tries to smooth out all the edges. So to boil it all down, it's a three-step dance: detect, swap, and blend. Now, the truly wild part is that all of this has to happen dozens of times every single second to look even remotely real. But that incredible speed, that constant pressure to be perfect, well, that's also its greatest weakness. So how do we take advantage of that weakness? Well, some really clever researchers have developed a defense system designed to do one thing: break that high-speed pipeline. It's called Gotcha, and the idea behind it is just brilliantly simple. It's a challenge-response system. Basically, to prove you're real, the system just asks you to do a specific, simple little action on camera. And yeah, that name is totally intentional. It's a nod to CAPTCHA. You know those "I'm not a robot" tests we all have to do online? Just like a CAPTCHA asks you to do something a bot struggles with, like picking out all the pictures with traffic lights, Gotcha asks you to do something a deepfake AI just can't handle. Okay, so let's see how this actually works in practice. Because the goal here isn't just to spot a fake, it's to actively force it to fail right in front of your eyes. The system uses four main kinds of challenges. It might ask you to simply move your head around, cover part of your face with your hand, press on your cheek, or even just shine a flashlight on yourself. Now, these things are incredibly simple for a real person, but for a deepfake generator, it's chaos. It introduces all these unpredictable things the AI was never trained to handle. And this is where it gets really, really cool. On the left, you see a real person putting on a face mask. Simple enough. But look at the right. When the deepfake is told to do the same thing, the AI just gets completely confused. It actually tries to blend the mask into the person's skin, creating this totally bizarre and obvious glitch. It's a dead giveaway. Here's another perfect example. The user covers their eye. Now look at the deepfake's attempt to copy that on the right. It completely falls apart. That heat map shows you exactly where human reviewers could spot the errors. The AI just cannot handle the interaction between the hand and the face, and the result is this distorted, unnatural mess. This chart really drives the point home. Researchers measured the visual quality, or degradation, of these videos. So real videos, on the far left, have a really low degradation score. They look great. Standard deepfakes, in the middle, already look a bit worse. But look what happens in that bar on the right when you introduce a simple gotcha challenge. The degradation score for the deepfake just skyrockets. The fake literally falls apart. These errors, these digital glitches, actually have a name. They're called artifacts. And this heat map shows exactly where people notice them. The red areas, you can see them concentrated right around the nose and eyes. That's where the digital mask just becomes totally obvious. The challenges make these artifacts impossible to miss. But of course, this isn't some magic bullet solution. As our defenses get smarter, you can bet the attackers do too. This has really become a technological arms race. You see, a really sophisticated scammer could start to anticipate these challenges. They could collect tons of data of their target doing these exact things, covering their face, tilting their head, and use all of it to train a much stronger deepfake model, one that's actually prepared for our tests. So how do we beat a smarter deepfake?
Simple. We don't just use one challenge, we use a whole sequence of them. And as you can see from this chart, while a really fancy deepfake might squeak by and pass a single challenge, its quality degrades fast as you add more. By the time you get to the fourth random challenge, even the very best deepfakes start to glitch out, and the fraud is exposed. And that brings us to the final and most critical question. This battle between creating deepfakes and detecting them is constantly changing. The imposters are absolutely getting smarter, and their tools are getting more powerful every day. So the question we're all left with is, can our defenses keep up?